When the SeaStar was first introduced several years ago, it came with two critical features for giving us high quality EAA images. The first is live stacking, and the second is dark frame subtraction. With live stacking of multiple frames, we can average out the background noise so we have smoother backgrounds in our image while reinforcing the signal from the deep sky object we're looking at. And with dark frame subtraction, we can remove what's called fixed pattern noise in the imaging sensor. Together, these have enabled people to take some pretty incredible images with the SeaStar smart telescopes. And more recently, ZWO added its intelligent denoise feature, which further helps to diminish background noise. But up until now, there was one key feature missing that could help us further improve the quality of our images, and that's flat frames. Hi, I'm Curtis, and welcome to my channel. In this video, I'm going to explain what a flat frame is, why it's important, how it works, and I'm going to show you several ways of taking a flat frame with your SeaStar. Now, I know that the SeaStar app itself has a very good video showing you the different methods for taking flat frames, but they do leave out some important details that I think everyone should know, especially in cases when the flat frame fails. So I'll go through those procedures and I'll give you my tips as well. As always, if you find this video helpful, please like it. That helps make it easier for other folks to find. And you may also want to subscribe so you can be alerted when I post future videos like this one. So what is a flat frame? It's a single exposure of very short duration, generally under 1 second and even much shorter than that, taken with diffuse light, uniformly illuminating the aperture on your telescope. And just like with dark frames, the SeaStar doesn't take a single flat frame. It will actually take multiple flat frames and average those together to create a master flat. Exactly how many flat frames the SeaStar takes, we don't actually know, and they don't say, but I'm sure they take at least 5 flat frames, and I'm guessing they take more than that since the exposure times are so short, and it wouldn't take very long to take a dozen or more flat frames and average them together. Okay, so what do flat frames do for us? Flat frames help us to address 3 different potential problems. The first and the most common is vignetting of the optics. The second is dust on the cover plate or filter nearest to the imaging sensor. These are often called dust bunnies or dust motes. And the third is something called photon response non-uniformity. So let's go through each of these. Vignetting will occur when anything in the optical path can block light coming in on the extreme outer edges of the aperture from reaching the imaging sensor. It could be baffles in the optical tube. It can be extension tubes out the backside of the telescope where we attach our camera. It could be a dew shield on front of the telescope. Anything in the optical path that can interfere with light coming down through the optics and reaching the sensor can cause a drop-off in the intensity of the light as we go from the center to the edge of the field of view. Now, we don't have access to actual flat frames from the SeaStar, at least not at this point. So I've borrowed a flat frame taken with one of my traditional astrophotography and EAA setups on my Celestron C11 SCT. And so this is what vignetting occurs. As you see, the image is very bright in the center of the field of view. The image brightness starts to roll off as you go to the edge of the field of view, and it gets the darkest when you go in the extreme 4 corners. And that's simply because not as much light is able to get to those parts of the imaging sensor as it traverses down through the optical axis. Now, I suspect vignetting in the SeaStar is much, much less severe since a very simple optical path, and there doesn't appear to be much in the way of restricting the light from getting to the sensor. Also, the sensor is quite small, and when you have a small sensor, it's less susceptible to vignetting. It only makes sense. The bigger the sensor it is, the bigger the area that you have to have uniform illumination. And if you have a small sensor like we have in the SeaStar, it's much more forgiving. Which only tells us that when SeaStar releases an S50 maybe with a bigger sensor, or goes to the 70mm aperture with a bigger sensor, flat frames may become much more important than they are with the smaller sensor and the smaller optics of the S50 and the S30. But flat frames are easy to take, and ZWO's made it very easy to take in the case of the SeaStar. So there's really no reason not to utilize them. So the first thing flat frames will help us with is the roll off and the light intensity from the center to the edge of the field of view, or otherwise called vignetting. So the second thing that flat frames can help us with is the impact of any dust on the cover plate for the imaging sensor, or even filters that are very close to the imaging sensor like they are in the SeaStar. Now, because that dust, whether it's on the cover plate or the filter, is not at the imaging plane, it will be out of focus, and what it will appear to be is a large fuzzy donut in our images. And here's an example of that. Now, this particular example shows you quite a few dust motes or dust bunnies in the field of view. Now, any dust or smudges on the outside aperture of the telescope will not show up in our image because they will be so far out of focus we won't notice them. So it's only dust that gets on the optics close to the imaging sensor. Now, since the SeaStar is mostly sealed, we're in luck. It's unlikely that we have that problem, but there's no guarantee over time some dust and dirt doesn't filter in there and get onto your sensor or one of your filters. And in that case, the flat field will help to remove that from the final image as well. Now, the last thing the flat field will help us with is something called PRNU, or photo response non-uniformity. Now, the pixels inside the imaging sensor are made in a semiconductor processing facility. These are CMOS sensors. And while the technology is pretty amazing, they're not able to make each pixel exactly the same. There may be small size differences among the pixels. There may be small electrical differences from one pixel to the other. And there are also lenses built on top of each pixel to help focus more light onto the individual pixels to make the overall imaging sensor more sensitive to the incoming light. And there can be variations in that as well. Now, these small variations in the manufacturing processes mean that each pixel may not produce the same number of electrons for the same number of photons that strike it, or it doesn't actually register as many photons as its neighbor, even when we shine uniform light on the surface. So small variations from pixel to pixel will also be picked up by the flat frame, and we can reduce or even eliminate the effect of photo response non-uniformity on our final images with flat frames as well. Before I demonstrate 3 different methods of making flat frames with the SeaStar, let me first discuss what we need to make a proper flat frame. The first thing we need is a source of diffuse light. And diffuse light is light that's coming at us from all different directions, not coming at us straight from a single direction. So a light bulb is not a good source of diffuse light. But we all have access to a pretty decent source of diffuse light, and that's a clear blue sky, because the atoms in the atmosphere scatter the sunlight so that the light coming to us is coming at us from all different directions, which is what we want in a diffuse light source. But we can make that an even better diffuse light source if we take a white sheet of paper or a white cotton cloth or t-shirt, and by placing these over the front of the aperture of the SeaStar, we're going to make very certain that we have a high quality diffuse light source. Now, another option for a diffuse light source is to use a tablet with the screen set to pure white. Now, the obvious advantage of this is we can do our flat frames inside the house or even at night when we don't have access to the clear blue sky. Now, the second critical element in obtaining a good flat frame is control over the level of the intensity of the light. We don't want too much light, and we also don't want too little light. Now, when I'm doing flat frames on my Celestron C11, I have to adjust the camera exposure and gain myself to get the right level of lighting. We don't have control over that in the SeaStar. It's all automated, which makes it super easy for us. However, we have to recognize that because we don't have control over that, it may fail, and many people will wonder, why has it failed? And the answer may be that you either have too much or too little light coming in. Those of us who are astrophotographers and like to use the sky as our diffuse light source will typically take the flat frames after the sun goes down at dusk. Some people do it in the morning twilight, just before the sun comes up and the sky is just starting to lighten up. The SeaStar app has complete control independent of us, and I suspect it has a exposure time in the millisecond range. So it can take many, many flat frames, so it can average them together to get a very good master flat. And don't forget, it also has to do flats for both of the filters in there, the UV-IR filter as well as the dual narrowband filter. And you'll actually hear clicking of the filters while you're taking the flat frame, indicating that it's moving the filters one after the other in and out. Now, the other thing about using the sky as your initial diffuse light source is you don't want to point to a bank of clouds, because that will not be diffuse light source. That will be more of a directed light source, and that will not give you a good flat frame. So how often do you have to take flat frames? If you notice, the SeaStar will take a set of dark frames every observing session, and it'll use that set of dark frames throughout the evening, so long as you don't change the exposure setting, in which case it'll take a new set of dark frames. And when you set up the next night, it'll still take a set of dark frames, even though you took the same length of dark frame exposures the previous night. And that's just the way ZWO has set it up. Now, frankly, if the temperature doesn't vary from night to night all that much, you really wouldn't need to take additional dark frames every night, but it's not going to hurt. Now, as far as flat frames are concerned, you don't need to take flat frames every night. You can if you want to, but you don't have to. When do you need to take a new flat frame? Well, if you change something in the optical path. So, for example, with my Celestron 11-inch SCT, if I were to rotate the angle of the camera, then I would have to take a new flat frame. If I put filters in place, I have to take a new flat frame. If I put a focal reducer in there, if I removed the camera and replaced it with a different camera, I would have to take a new flat frame. And if I put a dew shield on or took a dew shield off, I would have to take a new flat frame. Now with the SeaStar, since it already takes flat frames for both of the internal filters, and there's really only one other thing that you can change in the optical path, you seldom have to take a new flat frame if you don't want to. But if you use a dew shield sometimes, but not all the time, then you'll have to take flat frames when you put the dew shield on, and you'll have to take new flat frames when you take the dew shield off, because presence of the dew shield or absence of the dew shield will change the amount of vignetting, and the flat frame won't be the same if you don't take it under the same setup conditions. So let's take a look now at the 3 different ways of performing a flat frame. I already have the SeaStar turned on. You don't have to point it up like I have here. You can point it again at any point in the sky, away from the sun and not pointing at clouds. But if you have it flat, it's easier for things to set on the surface and not slide off. So we'll tap on the SeaStar image. We'll go down to Advanced Features, and then we'll go over to Image Calibration, and there's the flat shoot. So let's tap on Shoot, and I'm going to first use the white paper. So I have 1 sheet of white paper, hit Shoot. There's a shutter. There's another filter going in, and another, and it succeeded. So that happened very quickly. And that's with the small piece of paper. You could do this with a bigger sheet of paper, but the reason I don't like that is it may not actually sit nice and flat on the surface. So I prefer using a smaller cut piece of paper that can fit there on the surface and not be bowed. You don't want it to be bowed in any way, because if you're letting light in from the sides, that's not going to be a good flat frame. Okay, the second approach is to use a cotton t-shirt, a white cotton t-shirt, or I like to use a white cotton cloth, and I'll set that on there. And you want that so it's not wrinkled. You want it nice and smooth. So let's try that. Getting a little bit of wind here. Hopefully it holds in place. And there it clicks. You can hear the clicks of the filters going in and out. And that succeeded. And if it was earlier in the evening and it was too bright, that might fail. Then I could double up on the cloth, or I could add several pieces of the paper. Now the last approach is to use a tablet, and you'll have to set the tablet so that the screen is white, and you may have to adjust the intensity of the screen, and you can set that down on the surface there. You just have to make sure that it doesn't turn off, keeps turning off on me from time to time, and then hit shoot. And there we go. So any of those methods will work. You may have to adjust the intensity of the screen on your tablet. You may have to use more than one sheet of paper. You may have to use the folded over cloth. All of those methods to get the intensity within the range that the SeaStar exposure can deal with. So as you can see, taking the flat frame is actually very easy. Only takes a few seconds. Now there were several things I was able to verify about the SeaStar flat frame feature, which are worth sharing with you. First, I wasn't sure whether the SeaStar used a fixed exposure or not. At first, I thought it used a fixed exposure, but I'm sure it doesn't. And the way I verified that was I used the sheet of paper approach for the diffuser over the aperture, and I measured how long it took to take a flat frame with a single sheet of paper, and it took about 11 seconds. And I did that several times, and it was very repeatable. Then I used 5 or 6 sheets of paper, which is going to block the light so that there's much less intensity of light reaching the sensor. And I did a flat frame that way as well. And this time it took about 24 seconds. It didn't fail, it just took longer. So obviously there is a range of exposures that the flat frame feature is able to use to adjust so it can get a proper flat frame given some variation in the intensity of the light coming in. And I guess that shouldn't have been a big surprise. The second thing is, because of that, even though we astrophotographers typically do our flat frames at dusk or early in the morning when the sky is not so bright, I found that you can actually shoot your flat frames in the middle of the day, even when the sky is very bright. There's a lot of ambient light. You just have to put a lot more sheets of paper, or you need to fold over the cloth if you're using a cotton cloth or a t-shirt several times to block out a lot more of that ambient light. And the SeaStar still will produce a flat frame even with a lot of ambient light available, so long as we diffuse and diminish the level of intensity of that light using a thicker diffuser. Now there is one other thing that I discovered as I was using the flat frame feature, and maybe some of you noticed it as well. If you look at the writing down below the flat frame feature in the SeaStar app, you'll notice explanation about the flat frame. I take note of the first part of the sentence that says, if the built-in flat field. Now that suggests to me that ZWO already had a flat field algorithm working in the background, unbeknownst to us, before they made it available for us to do ourselves. Sounds like they created a factory flat field. I don't suspect they created a flat field for every single individual SeaStar unit, but they probably made a generic flat field and installed that in the app, either at the very beginning when they started shipping the first SeaStars, or somewhere along the line when in an app update, which they didn't tell us about. So I find that phrase very interesting, and I've posted a question to the ZWO Tech on their online forum to verify that that actually means that they were actually using flat fields unbeknownst to us, maybe all the way from the beginning of the first shipments. If they were doing it from the beginning, you may not notice a very big difference if you do the flat field yourself from images you took before you had the ability to do your own flat fields to now when we can do that. So keep that in mind if you're looking at this and saying, I don't really see a big difference. Well, maybe it's because they were doing flat fields all along. As always, I hope you found this video useful. If so, please tap that like button. It makes it much easier for folks to find my videos. And you may also think about subscribing so you can be alerted when I produce future videos like this one. So thank you for watching, and until next time, clear skies.